Today we're controlling two IronHorse VFDs via EtherNet IP with a productivity PLC, one ACN using Explicit Messaging, and one ACG using Implicit Messaging. I'll show the exact parameters, the EDS setup, and the ladder so you can replicate this easy and fast. I won't cover module installation as it's already covered in the Modbus TCP video linked above and in the description. But I'll note that those instructions for the ACN ETH show switch 1 up for Modbus TCP. For Ethernet IP, this switch needs to be down. Often either implicit or explicit messages are used for Ethernet IP communication with devices such as drives. Explicit messages are generally part of ladder logic and can be easily controlled and monitored. Implicit messages can occur outside of normal ladder logic programming and are very rapid, often considered real-time. All addressing is covered in Appendix B of the ACG manual and Appendix C of the ACN manual. We'll look at that when we get into programming. We'll assume your motor parameters are already set. Now let's put the drives on the network. On the keypad, set DRV for 4 for Fieldbus control, and FRQ to 8 for Fieldbus reference. Then we'll configure the network. The IP is in CM 10 through 13, subnet in CM 14 through 17, and gateway in CM 18 to 21. The ACG stays at 192.168.1.101, and the ACN gets 192.168.1.31. The defaults will remain for the mask and gateway. For implicit messaging on the ACG, set CM29 to 1 for input instance 71, and CM49 to 1 for output instance 21. For the ACN, these are CM23 and CM24, but we're using explicit messaging, so no change is needed. To save the Ethernet settings through a power cycle, set CM94 to 1. We're starting with the ACG explicit message sample programs from our site. We provide example programs for every drive and PLC we sell. And we have a bunch of videos on using Ethernet IP and other communication protocols with all our PLCs. Just go to the video page linked above. Under Hardware Config, add the ACG and assign an IP address and tag names. The program triggers the messages every 50 milliseconds using a timer and counter. There are 6 get data and 6 set data instructions. You can think of these as read and write operations to the drive. Here's the first get data. We use service 14 to read class 41, instance 1, attribute 6. This returns the drive state. The remaining gets read forward run, reverse run, drive ready, at reference, and output frequency. Set messages use service 16 to write into class 41 and 42. Frequency reference, forward run, reverse run, fault reset, and accel decel times. We don't see much besides drive ready. Let's give a speed and run forward command, and the drive responds as expected, and we receive the expected feedback. Let's dive right into the implicit messaging program. This is based on the sample program. I'll add it to this program so both drives run in a single program. Under Hardware Config, add the ACG and assign an IP address and tag names. Then add an I/O message for assembly 71, which has all the elements we want. And an output message to assembly 21 and another array. The latter is really just enabling the message and some logic to make the input and output arrays more user-friendly, which I've pasted in from the sample program. You could use these input and output arrays as is, but it makes the logic easier to follow. Let's send a run forward and a speed in RPM. Note that we're using RPM here based on the output assembly we're using. If we needed to use frequency, we could have set up our implicit messaging to use instance 101 or 100. So with both drives online, the ACN responds to the explicit reads and writes. The ACG streams it via implicit communication. Commands go out, feedback comes back, everything operates as expected. That's it, 2 IronHorse drives on Ethernet IP with a productivity PLC. For sample programs, manuals, and more videos, check the links in the description. For more drive videos, look here. To buy drives for your applications, click here, and subscribe to be notified of new products and solutions.